Okay, so now let's look at the different types of predictions that we can make. So we can either do interpolation or extrapolation. So what is this? So interpolation is when we are making a prediction that is within the range of the data. So let's just say the X values that they've given you range from, I don't know, 20 to 60, okay? And let's just say you're trying to work out, based on the line of best fit, what the value is going to be, what the Y value or the response variable is going to be when your X variable or your explanatory variable is 40. Now 40 is within that range of data. So therefore, when we make this prediction, it will be interpolation. So interpolation is predicting a Y value from an X value that is within the range of the given data. And we say that interpolation is reliable. And the reason why it's reliable is because we already know that the trend exists for the given data range. So we already know that, let's just say the trend is increasing. We already know that between 20 and 60, the trend is increasing. So if we predict a certain value that is within this data range, we already know the trend exists, so thereby the value that we predict is likely to be reliable. Now, extrapolation is when we predict a Y value from an X value that is outside the given range. So let's say we were asked to predict 80, what the Y value is going to be when the X value is 80. Now, this one is going to be an unreliable prediction because we don't know what happens after 60 or before 20. The data might just start going like this, and the prediction you have made might be over here. You don't know what happens after the given data range. You might, base it on evidence, but still it's going to be unreliable still. So that's why extrapolation, unreliable, predicting outside the data range, interpolation, reliable, predicting within the data range. Okay, let's look at an example of that. So the scatter plot below shows the rainfall in millimeters and the percentage of clear days for each month of 2008. An equation of the least squares regression line for this data set is given to you. So here, the data is drawn out for us. They've also worked out the equation. So now the equation you can only work out if they've given you the specific data in that table. If they've just given you a scatter plot, never try working out the least squares regression line. It's too hard to be reliable. I know some students who have gone and put every single value into the calculator, and it's not going to be reliable. So whatever equation they've given you, use that. If they haven't given an equation, it means that the question doesn't require an equation. Okay, so use the equation of the least squares regression line to predict the rainfall for a month with 35% of clear days. Write your answer in millimeters, correct to 1 decimal place. Okay, so we want to predict the rainfall when the percentage of clear days is 35%. So all we do is we put in 35 instead of percentage of clear days. So rainfall is equal to 131 minus 2.68 times by 35. So you would have done linear equations in Unit 1. So this one should be pretty straightforward. And then rainfall is equal to 37.2 millimeters. So just do it on your CAS. Now the question is this prediction reliable? And the answer is no. And the reason for that is if you look at the data, what's the range of the data? So the data ranges from around, let's say 7-ish to 27, let's just say. So the data ranges from 7 to 27, or in this question, more reliable, it's given 6 to 26. Doesn't matter too much as long as you're reliably accurate. But just given the range of the data, we are predicting for when there is 35. That is way outside the data range. So no, we are extrapolating as we are predicting outside the data range, so therefore the prediction is going to be unreliable.